Hello everybody. Today we're going to look at the idea of accuracy and errors in our measurements, and that's something you'll need to consider when we start looking at your investigation. So here we've been given a quote which is a measurement is only as accurate as plus or minus a half of the smallest division on the scale. So when we start looking at this example here, which is we've got 180 metres, our smallest division here is in fact 1 metre. So therefore our measurement's going to be plus or minus a half a metre. So then we know that this particular measurement has to be between 180 take a half a metre, which will be 179.5 metres, and 180 plus a half, which will be 180.5 metres. Alright, so that's an example using a distance. We can do the same thing with any value. So looking at example with kilograms, obviously it's going to be plus or minus a half a kilogram there. So we know this thing here is going to be between 175 take a half, so somewhere between 174.5 kilograms and 175.5 kilograms. That's our error of margin that we would be expecting there. If we go to this one here, we're looking at the nearest millimetre, so therefore that will be between that take a half, so it's going to be 499.5 millimetres. So this would be quite accurate if you're actually looking at what we're doing here, and 500.5 millimetres. Right, so there's some examples of how you actually work out the what would be the expected accuracy of your measurement. Coming down to the next section, we need to look at the definition of what an error is, and an error is the difference between what you think it is, or your estimated or your measured value, and the true value. Alright, so I'm just going to do one example here for you. So if you thought it was 20 metres, or you measured it to be 20 metres, and the actual value was 22 metres, we want to work out what our error is. So our error in this particular case is going to be the difference between those two, and that's going to be equal to 22 take 20. Now you always make it so the biggest number goes first and the smallest numbers go second, so you always get a positive value. So that's a 2 metre error in that. Now that is quite a big error when you're looking at that sort of distance. Obviously if you're looking at a distance over thousands of metres, that probably would be okay. Now often we present this value as a percentage error. Alright, so the percentage error is simply the difference between the two, which is our value which we just worked out there, so it's our error, 2 over our expected value, the actual value, which is 22, and then we convert that to a percentage by timesing by 100 to get that to a percent. So this is the sort of calculation you do on your calculator. So if we go 2, divide that by 22, and then we times that by 100, that will give us what our percent error. That's 9.09% error. For most things, if you're doing at school, you know, if it's less than 10%, you'd probably be quite happy with that sort of value as a percent error. Alright, so that's the idea of what we're doing there. Now, there's some questions for you to have a go at doing there, and they're in exercise 1C1 and exercise 1C2. Again, the idea is to have a go at doing those, make sure that you get the concept, so you can actually incorporate that in your investigation. Alright, we'll talk to you in class. If you have some problems, make sure you catch up with me. See ya.